Hello everyone, I am Ayush Singh pursuing BCSC from Sri Venkateswara College of Engineering, and today in this video we will be talking about applications of scheduling in processing of the operating system. So let's first talk about scheduling in operating system. It is the systematic approach used by an operating system to manage the execution of processes and threads. It determines the order and duration for which each process will access the CPU, thereby ensuring efficient use of system resources. Key aspects: process management. It involves tracking the state of all processes and deciding which one should be executed next based on defined criteria. Resource allocation efficiently allocates CPU time and other resources to ensure that processes run smoothly and without unnecessary delays. Goals: to maximize CPU utilization. It aims to keep the CPU busy as much as possible, minimizing idle time by ensuring that processes are efficiently scheduled and executed. It also minimizes response time, reduces the time from when a process is submitted until it produces its first output, enhancing user experience, especially for interactive applications. It minimizes turnaround time. It seeks to reduce the total time taken from submission to completion of a process, including waiting and execution times. Prevent deadlock. It implements strategies to avoid deadlock situation where processes are unable to proceed because they are waiting for resources held by each other. Understanding operating system schedule. Process arrival. New processes arrive in the system and request resources. Process selection. The scheduler chooses the next operation to be executed based on the algorithm. Process execution. The selected process is allocated CPU time for execution. Process completion. The process completes execution, releasing resources and possibly entering a waiting state. Importance of scheduling in operating system. Resource utilization. Scheduling aims to maximize the use of CPU time, minimizing idle periods and improving overall system performance. Fairness. Scheduling algorithms strive to ensure that all processes receive a fair share of CPU time, preventing starvation or excessive delays. Responsiveness. Interactive processes like user interfaces require prompt responses, which scheduling algorithms can help achieve. Types of scheduling algorithms. FCFS, which is first come first served. Once a process starts execution, it continues until completion without interruption. SJF schedule. Scheduling decisions are made at the start of the process and they remain fixed throughout its execution. Third one is priority based scheduling. Scheduling decisions can change based on the current state of the system, such as process arrival or priority changes. Fourth one is round robin scheduling. A process can be interrupted and its CPU time allocated to another process based on priority or other factors. Let's talk in detail about first come first served scheduling. Process arrival. Processes are placed in a queue based on their arrival order. Process selection. The process at the head of the queue is selected for execution. Process selection. After execution, the process is removed from the queue and the next process is selected. Shortest job first scheduling or SJF scheduling. If we talk about advantages and disadvantages, in advantages, minimizes average waiting time. This is because shorter jobs are executed first, reducing the overall time spent waiting in the queue. It also optimizes CPU utilization by prioritizing shorter jobs. The CPU remains busy for a longer duration, leading to better overall system performance. In disadvantages, difficult to predict the execution time of a process. In advantage, the SJF algorithm assumes accurate knowledge of execution time, which is often difficult to estimate accurately in real-world scenarios. It can also lead to starvation of long-running processes. If a constant stream of short jobs arrives, long-running processes might never get a chance to execute, leading to unfair resource allocation. Priority-based scheduling. In high priority processes with critical or time-sensitive tasks. Medium priority level processes with moderate importance such as background tasks, and low priority processes with low importance such as file transfer or batch jobs. Round robin scheduling, time slice. Each process is allocated a fixed amount of CPU time. Process execution. Processes run for their allotted time slice, then move to the back of the queue. Context switching. When a process time slice expires, the scheduler switches to the next process in the queue. If we talk about real-world applications of scheduling algorithms, server management, scheduling is used to allocate CPU time and resources to multiple applications running on a server. Network routing, scheduling algorithms help prioritize network traffic to ensure efficient delivery of data packets. Database management, scheduling is used to handle multiple transactions and queries efficiently, optimizing database performance. Cloud computing manages resource allocation for virtual machines based on workload demands, optimizing cloud service efficiency. Multimedia processing manages the scheduling of audio and video streams to ensure smooth playback and minimal latency. Manufacturing optimizes production schedules in assembly lines to minimize downtime and improve throughput. If we conclude, efficient scheduling is in operating system is essential for maximizing CPU utilization, enhancing responsiveness, and ensuring fair resource allocation. By understanding and implementing various scheduling algorithms such as FCFS, SJF, priority-based, and round-robin system can optimize resource use and meet driver process requirements. Real-world applications from server management to multimedia processing demonstrate the significance of scheduling for smooth operation and performance. Continuous adoption and monitoring further enhance scheduling efficiency, making it a critical component in both traditional and modern computing environments. That was all for this video. Thank you.